Hello and welcome back to another video. In this problem, we have to explain using theorems 4, 5, 7, and 9 why the function is continuous at every number in its domain and to state the domain. So we have r of t is equal to e to the sine t over 2 plus cosine of pi t. So what we're going to do is we're going to take functions that we can find within R. So a of t is going to be e to the t. B of t is going to be sine of t. C of t is going to be 2, and d of t is equal to be cosine of pi t. And we can write r of t as, this is e to the b of t. We can think of this as a of b of t. Because it's a, it's e to the t, but we're not plugging in t, we're plugging in b of t, which is sine of t. And this is over, 2 is c of t, plus cosine of pi t, d of t. And so what we can say is that r of t is equal to a of b of t times 1 over c of t plus d of t. And therefore, we can take the continuity restrictions from the domain restrictions of these individual functions, and if all of these functions have particular, or rather if any of these functions have particular domain restrictions, then that results in a continuity restriction for the whole function, right? So if we look at these, right, we know from Theorem 7 that e of t, which is an exponential, sine of t, which is a trigonometric function, 2, which is a polynomial, and cosine of pi of t, which is a trigonometric. All of these functions are continuous for all values in their domain. Therefore, a of b of t is continuous for all values within its domain. So e to the t exponential doesn't have any domain restrictions. Sine of t doesn't. So a of b of t, right, the numerator we can think of it as, has no domain restrictions. And then 2 has no domain restrictions. Cosine of pi t has no domain restrictions. So these don't have any restrictions. And therefore, the only restriction is that the denominator, 2 plus cosine of pi t, cannot equal 0, right? The value of the denominator cannot equal 0. Therefore, cosine of pi t cannot equal -2. Cosine is a function which oscillates between -1 and 1. It never hits -2, so therefore there's not even a restriction there. And therefore we can say that r of t is not only continuous at every number in its domain, it is continuous for all real numbers.